I really need to tidy my desk up. Jesus Christ. Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down and subscribing if you haven't done so already, because that'll help me out immensely. Now, today we're going to be looking at a technique of bridging two amplifiers, power amplifiers, together to increase the power output. Now, it's not a new concept. It's been around for several years, several decades even, I think, and has been used in a lot of car audio, especially because they're a 12 volt source, and some of those installations can produce 100 watts per channel, which is impossible from a 12 volt source. So bridging is what they do. Now, this diagram here shows the concept of how bridging works. I did do a video a few years ago about the subject, but I didn't have any practical demonstration. Today I do. Now, I'll just go through the explanation of this. We have two amplifiers, and they must be both the same brand, same design, same power output, etc. Secondly, they must be capable of driving 4 ohm loads, because we've got a speaker driver here connected between each output rather than going to ground, and that's the third prerequisite. The speaker cannot be connected to ground, or else it won't work. So take, for instance, we've got an 8 ohm speaker here. Each amplifier is going to see 1/2 of that impedance. So each amplifier is going to see 4 ohms each. So unless the amplifiers are designed to run at 2 ohm loads, which most are not, you cannot use a 4 ohm speaker. You will instantly destroy the output stages of each amplifier. So the way the concept works is, with this bridge adapter here, we have an input coming in with a signal, and one side of it is producing a 0 degrees or non-inverted output, which is fed into the first amplifier, which comes out the amplifier at 0 degrees again into the positive of the speaker, and conversely the second output of the adapter produces a 180 degrees out of phase signal with the first one into the second amplifier, which is then pushed into the negative of the speaker, and the resultant output is a 0 degrees signal. So when the amplifier is working, we've got the 0 degree signal coming in that way and the 180 degrees signal going out that way. And that's pretty much all there is to discuss about the concept. There's nothing much to it. Now, with this arrangement, say each amplifier was capable of producing 50 watts into 8 ohms, and we could assume, just to keep the math easy, that at 4 ohms, remember, because this amplifier will see half the impedance, at 4 ohms each amplifier produces 100 watts. So when you combine the two together, you end up with 200 watts, theoretically. In the real world, it's more like 3 times the power to 3.5 times the power, maybe a little bit less. It depends on the output stage design and the power amplifier design. So how do we achieve this bridging adapter? With our old friend, the op amp. And there's the circuit there for the adapter. Now, it's based on a design by Elliott sound products. I will put a link in the description to that article. I think it's project 106 from memory. Anyhow, we've got any standard dual op amp here. Can be anything, and any 5532, TLO72, LM833, etc. Technically speaking, you could get away with only just 1/2 of this circuit using the inverting amplifier instead and just pass the left straight through. However, it's always a good idea to have a buffer between the outside world and the amplifiers you're connecting it to. Now, got an input capacitor here to block any DC, because there will be slight DC offset here on the input pins. So that just stops it feeding it back into whatever is the input signal is, a 100k ground reference resistor, and a 1k stopping resistor to stop any noise being picked up by the op amp from the cable. Going into pin 3 of one half of the op amp, pin 2 and 1 are directly connected together, forming a voltage follower, and that the output then goes through a 100 ohm resistor to our left output, which is 0 degrees. This just stops the op amp from going into spurious oscillation, depending on what it's connected to. Conversely, we've also got the input coming down here into this inverting amplifier, which again is configured as a voltage follower, so this is operating in unity gain because of this 100k feedback resistor and 100k input resistor going into the inverting input of pin 6. Pin 5 goes through a 1k resistor to ground, and it's grounded at the same point the 100k resistor is. It's just like a star earth really. And the 100 ohm resistor here on pin 7 going to the right output, which is 180 degrees out of phase with the left channel. Now it's best to actually connect this adapter directly to the inputs of the power amplifier rather than into the inputs of the analog inputs on the RCA sockets of a stereo amplifier. However, you could do both. I forgot to mention one other prerequisite about this is that you cannot use it with an already bridge-tied amplifier, because they already have the two separate outputs. They already have two separate amplifiers connected to a speaker. So if you were to connect this adapter to it, well, it would work, but you would only be coming off of one of the amplifiers. So then you need an identical amplifier which is also bridge-tied, and it defeats the purpose because you're now just bridge-tying two bridge-tied amplifiers together and getting the same result. So yeah, you can't use a bridge-tied amplifier, it's not going to work. But any other amplifier, Class AB, Class A, even Class G, I would say you could do it with too. But it's up to experimentation. Now, I will preface this by saying that if you attempt to do this at home, you're doing so at your own risk, because you can run the risk of damaging loudspeakers and damaging amplifier output stages if you do something wrong. So, yeah, word of caution. Plus, you're also messing around on the inside of a device that's powered off the mains. So let's look at a breadboarded implementation of this circuit. Well, which is handily right here. So I'm using an NE 5532 here. I've got a 1 microfarad input blocking capacitor, which is connected to my signal generator. Plus minus 15 volt supply, and I've got a probe, oscilloscope probe here on the blue wire, which is going to one channel of the oscilloscope, and the yellow wire here in front is going to another probe, which is going to another channel of the oscilloscope. So the yellow wire is the 0 degree output, and the blue wire is the inverting output. So now all I have to do is just power it up and look at it on the scope. Now the circuit's currently off, and you can see that there's a bit of bleed through and a lot of erraticness going on there on the scope screen. That's perfectly fine. That's just, going through the circuit passively. So if I power it up, we can see that we've got two outputs. For some reason, I've got the blue one on the wrong voltage per division. There we go. And I'm putting a roughly, I think it's about 670 odd millivolts in, something like that, 680. And we're getting close to the same amount out evenly on both of the channels. And we can see that the blue trace is inverted from the yellow trace. So we know that the circuit is working. So what do we do now? Well, we can just stand here and stare at the oscilloscope screen for a few hours and just taking it all in. And that's exactly what I'm going to do. No, I'm going to connect it up to an amplifier. Now, I'm going to connect it up to that 15 watt plus 15 watt stereo amplifier project that I built last year. Even though that's a single-ended 15 watt amplifier, not a bipolar. But it's fine. It should still work the same. I don't see any reason why not. It's just that it's not using the same common supplies, so that may become an issue with single-ended versus bipolar, because this adapter is bipolar. It has two personalities. No, So yeah, that's what I'm going to do is I'm going to dig out the 15 watt amplifier and I'm going to open it up. Now I haven't seen the inside of this for quite a while. I forgot how well laid out it was. And I've noticed that all these sticky things that hold cables and stuff are still stuck to the cabinet and haven't lifted. Right, so what I want to do is I want access to the inputs of each amplifier, so I'm going to actually disconnect the preamplifier from this. I believe I've still got a cable, may still have a cable that will plug into these connectors, because if not I'm going to have to make one. It's going to be annoying. Just so I can connect the circuit to it. But first, before I do any of that, I want to make sure of one thing. If it can drive a 4 ohm load for a start, and secondly what the power output into 4 ohms is. So that's the next thing I'm going to do, is set up to do that. Okay, everything is set up. I'm hoping the amplifier still works. I've got it connected to the left channel. I could have easily connected to the right channel, makes no difference. So I'm into 4 ohm loads. The scope probe is connected to, well, the yellow channel of the oscilloscope, and it still turns on, which is a good sign. Relay went click, so I'll just give it some volume. I've got about 670 millivolts going in. Yeah, I can see it's pretty stable into 4 ohms, which is good. So I'll wind that up till it clips, which is about there. So I'll drop him off till the clipping resolves itself. We've got approximately 25 volt peak to peak there. It's not in times 10 mode on the oscilloscope, so 25 volt peak to peak, yes. That's going to give us roughly 20 watts, I believe. Very close indeed, 19.5. Okay, so if you were to multiply that figure by 2 now, because it's 2 amplifiers, that'll give us nearly 40 watts of power. That's the theory anyway. So now I need to find some JST connectors that are already made up and plug them into the amplifier. Then connect the adapter to that said cable, and then connect the amplifier output to the dummy load on 8 ohms. It cannot be on 4, and then just measure the resultant output. So I'll get busy doing that. I've got the thing now reconfigured. I was thinking, why do I need to find another connector to connect the circuit to when there's already one in here? I'll just use the other end of it and disconnect the preamp. So I've done that. It's all very dicey. I've got like clip leads going off to the breadboard over there. The breadboard is currently powered up from the power supply, but the amplifier is turned off. I've got it into 8 ohms dummy load over there, going into the oscilloscope, and I'll show you how it's connected to the amp. Now I don't know what this is going to do, because this being a negative ground instead of a bipolar, I'm not sure what it's going to do. Probably nothing disastrous, but we'll soon find out. So take note of how it's connected. The black lead is connected to the right hand channel output, and the yellow lead is connected to the left hand channel output, and the ground is disconnected. So what I'll do is I'll just turn my oscillator down to nothing, so it's not outputting a signal directly into the amplifier straight away. Alright, turn it on. Well, nothing disastrous happened. Whilst you look at the scope screen and I turn the gain up, I will keep an eye on the circuitry to see if it smokes. Whoa. Yeah, it does work. And it's getting to a certain point where it just breaks up and doesn't like it, so I'm not going to go any further with it too much. And that's about as much as I want to push it. So it's 38.7 volt roughly. Well, the results aren't impressive. It's only like 23 watts. But the concept works. So what I might do now is I might actually inject it directly into the preamp instead of how I've got it now. Just to see if it operates any differently. That way I can use the volume control on the front. Got the inverting and non-inverting inputs going into the left and right respectively, and it's grounded into the preamp input. So I'll just turn the amplifier on again. nothing bad happened. So it's still connected to the load. Yeah, it's not the greatest. It's still pushing around the same amount of voltage out. So where the concept works, with this particular amplifier, it doesn't actually benefit from being bridge tied, but it is what it is. So at least we know the concept works, but this amplifier probably wasn't a good candidate for that. However, it is what it is. So anyway, I hope you enjoyed this video, and if you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is Astro 3 saying see ya, have a great day.